Welcome back to the Cinema 4D to Houdini translator series, and this video is going to be all about tags. You know, selection, vibrate, target. I've gone and mapped all the closest Houdini workflow or tool to all those favorite tags, so let's go find them. First tag is align to spline. Now this one's very similar to path deform that we've seen in deformers. In fact, it's exactly the same. The only difference is we pack the geometry before. If we unpack it, our flippy will bend with our curves, but if we pack it, which just means all the geometry gets turned into one single point. And let's go to the geometry spreadsheet. We can see we only have 1 point. When we unpack him, we have all the different points available. Now the path deform has all the things that you can imagine, like our curve U position, which means we just have this where we can animate him along if we want to keyframe that or not. That is our align to spline tag. Next up is the idea of targeting or look at tags. Now all this one is using Mops aim with our geometry coming in here and being packed. We have to pack it first, otherwise it doesn't work. And we're taking a sphere here that we're animating around, and Mops aim is aiming our flippy at it. And if we want, we can unpack after, so we have all our geometry and able to be manipulated. But there's a couple other different ways to do this and times that you'd probably use target tags or look at tags. We have another version here, which might be the look at camera. Right now, I'm not looking through the camera, but what I'm doing here is I have a grid that I've painted a very happy face on, and we're packing that into 1 point again, and then throwing it into a Mops aim. And then through our second point, we're getting our camera, but we're getting our camera just as one single point, and then that's going into our Mops aim. So if I come into my camera and lock it, this guy will always look at the camera. The cool thing with Mops aim that we've seen before is we can constrain up. So this guy will always look at the camera, but we'll never have an angle to him. See it not? Now, what about other times that you might need a target? Maybe with a light or the camera, for instance. Let's go back up to our top, and we have our camera here, which we can see is all the way up here. And let's go into the camera and make it look somewhere else. I don't know, up here. Now we can see our camera is not looking at the center, but let's create a null. And let's say look at is using one of these shelf tools up the top. If we come to constraints, all right, so first, if we highlight our camera or select it in the viewport and then press look at, and then come here and select our null, press enter, and then enter again, you can see our camera is now going to be looking directly at this null, which is really cool. And I can come up here. This is using a constraint network, which I'm not going to get into right now. But essentially, if I just grab old mate null here, the camera's always going to be looking at it. And you might use the same with a light or anything like that. So this is done outside of our SOPs or our geometry containers here, and done on the objects themselves. And you can see this little wavy thing that just says that there is a constraint attached to this camera. This one's a bit funny. It has a few different applications, but really it's just allowing you to edit your animations you've already done. So if I come to this transform, I have an animation on the y-axis, just making this ball bounce. Now you can see the animation is cycling, and that's because I have the cycle motion effects node activated, which you can get to by coming here and go motion effects, cycle. Pretty easy. And I'll open up this motion effects guy here, to which I have cycle applied, which is pretty good. And if I come into this motion effects view and press the blue thing here, we're able to see what it's doing. Cool, nice and easy. Next one we have is filter. And filter just smooths out your animation. So let's have a look here. We can see the old animation in purple and the new animation in green. And I can adjust this so it filters out more and more of your animation. Another one is shift. Let's have a look at this one. This will just shift or extend your animation, brings it forward or offsets it a little bit. Sometimes you need that. Another one we have is noise, which I'll introduce you to a bit more in a second. But let's just add noise to our animation. So we have to do that in a funny way. We have to add a noise node and then add a math node, which, yeah, fun, right? And we add them together and we make sure combine these using an add. And if I put it here and output it, turn off shift, we can see we just get a little bit of noise added to our animation. Another thing you might use inside of the track modifier would be a posterized time. Now, how you might do that in Houdini is a little bit different. We don't use the motion effects. We create a time shift. And if I come to this time shift, it's just going to speed it up. So your frame count times 2. And then I'm going to create another time shift. Next one slows it down, times it by 0.5 or divides it by 2. Again, just putting it back to its normal speed. And that's the animation we have. It's posterized. And if we want to do more, like for instance, if we want to make it a 3 frame, then it's probably going to be easier to like divide by 3. There, nice and easy. And that's track modifier. And that's all the things you probably need to know to get all those favorite effects from track modifier tag. Next is a fun one, Vibrate tag. Now this one, there's a lot of different ways that you can do it. And I'm going to go through all 4 now. First up is exactly what we're just doing, which is I've got a translate, which is our position in XYZ. So if I right click translate and go motion effects, we can obviously create many different things here. And one of them is noise. So what that's going to do is open up one of these and it's going to bring in all our parameters that we have here. And then it's going to add noise similar to what we just seen before. And then we can choose how that noise is. We can obviously animate these as well, how big the amplitude is. And that's just the general idea. So let's just quickly do it. Let's go transform. And let's not do position. Let's actually do rotation, motion effects, noise. And we get to bring up this cool little panel. And we can see it opens it up in one of our motion effects things and just adds noise. And the cool thing is we just get to see it here. Now this is a bit too much. Let's go amplitude 180. Just chaos. We can make it slow down. But that's our Vibrate tag. The next way to do it doesn't involve using motion effects because that can be difficult, is to pack our geometry and then get an attribute noise on position. This is kind of the same idea that we had with align to spline. If we unpack it, it's going to distort our geometry. But if we pack it, it's going to do it to the middle point of our packed geometry here. And then we can unpack the geometry after, and we have them all uniformly moving. Now to take that same concept of applying one noise to every single point, as opposed to them moving on their normal, they might just move around. We can also do that by creating some attribute noise that goes over detail. Now we have attributes here, which this is a whole thing, but essentially you can put data on points, on vertices, and on primitives. But you can also do it over the whole geometry, which I've done here. We have this detail attribute and we have noise 0, 1, and 2, which is going to be used for XYZ. And then we can use an attribute wrangle here to pretty much put that on every single position point. So what's going to happen here is we have our detail noise. This does involve a little bit of code. Our amplitude, and we're using our P, which is our position, plus equals the noise times amplitude. And then that'll vibrate our flippy. And then if we want to speed this up, we can come here to our animation and make it really quick. And it's just applying the exact same noise to every position, which is kind of the exact same thing that's happening here, but a little bit different. We can also do it with a transform by chucking in code into our translate, which just is on a transform node. And that's how it's written here. And this is how it will apply. The same noise on those same positions, just done a little bit differently. And finally, we have the last way, which is kind of the same idea, but creating a noise and everything all inside a wrangle. And we can see that here, but less important. It's just more to show you that there's more ways to skin a cat. There's actually 4 of them. Next up is our rigging. I'm not going to go all into rigging, but there is a lot there. When I come in here, we'll go to animation and go to rigging. There's a whole lot of nodes here. I'm not going to go into them. I'm going to go into some of the ones that we tend to hack for other purposes. So here I have test geometry, and I've modified him by pulling some of his nose out, and I've done another modification by pulling his tail out. And then we have a blend shapes. So this is essentially the pose morph tag in Cinema. And we can blend. So we can blend in pose morph 1, and then we can also blend in both pose morph 2. So we can have them at any function. Obviously, this can be used for characters for morphing shapes, but as I'm sure you're aware, this can be really used for, I've got like a cloth simulation that just comes in here with a bit of noise. Nothing cool. But if I set the start plus 50, so we start with our geometry already twisted, and then we offset it by negative 240 frames, and then we blend between those two with some keyframes. We can see this is not the best blend, but we are going to get, let's go, a looping cloth simulation. Posemorph is powerful. So next is protection tag. You don't really need a tag in Houdini. There's many different ways that we can do it. Like if I come back to this blend shape and right click here, we are able to lock parameter. And that parameter is now not allowed to be adjusted. It's just set at what it is or with its keyframes. I can come here and go unlock parameter at any time, but I'm just also going to go to the camera, and let's go to our camera. This is locking it to able to transform it. And you can see we can move our camera around. But if I come here and go lock parameter, and now it just will not translate. So you don't accidentally move your camera. You can see I can't even move these numbers. And then if we want to unlock them, unlock parameter, and now we can do whatever we want to that camera, except for move it away from the null, because it's looking at the null. But every parameter that you can see is available to have a lock done to it. Next up here is our UV or material tags. I've got a box here, and there's a few ways to get UVs in Houdini, but the best one is just the classic UV texture. And you have a few different ways to do it. It will come in as orthographic, which will just put it on the top, but we can select many different ones. Polar, rows and columns, perspective from camera, and if we define our camera as camera 1, we get our perspective from that camera, which is all really cool. But the one I like to use the most is face. Now in Houdini, you need to set the UVs essentially first. And then we have a UV transform here, which just allows us to transform this. And if I press space 5, we get to go to UV mode, UV view mode, and we can see what's happening a little bit more. Let's move this around. That's our geometry. It being in the bottom left-hand corner is kind of equivalent to it being 0.5 and 0.5 here. And if we go back, we can see what's happening. Just moves our UVs around. Again, there's a lot of different ways to do it. We have another one, which is UV unwrap, and this gives us a slightly different, this kind of works like a triplanar or maybe box projection. But for this box, let's just go here, layout square. And if we can have spacing as well, which this kind of doesn't make sense just yet, but when I go into the view here, we can see it's just automatically laid out all our squares across our UVs. And if we do spacing, it just gives us some breathing room with our squares. We have another one, which is UV project, and we have a few different ways to do it, similar to the other one, plastic wrap, which we can see if we go in here how these are working. And then this is what it looks like on a grid as well, which we can scale down, or scale up rather, or like 25. So our texture is there. UVs aren't the most exciting, but they're useful, right? Next, we have a pin UV. Now, how UVs will work in Houdini is you just do the UV texture before you do any of your movement. So we can see the inverse now. And you can see the UVs are slipping and changing because the UVs are being applied on every single frame as the geometry bends and contorts. Next is material tag. Now, I've got two boxes here, this box and this box with materials applied to them. And how that works in Houdini is I have to select what it gets put on as opposed to putting it on the geometry in a little tag. So let's just create a new material tag and come in here and nothing has happened. So first I want to add another material because there's two. And if I come here and let's select the material. So to do that, I have to find it. And I can see that it's material here. There's a few places to store materials in Houdini. We have the material thing here, but we also have materials that we can dump wherever we want. So let's come to tags and the map net here. And then we have Karma 1 and Karma 2. These are not greatly named, and you can see it applies to everything. But let's select what we want it applied to. And if I select this, it's only going to apply it to that one bit of geometry. But if I come into our selection, which we have to click this little guy here, and then go 3D connected geometry, this one, it's going to apply there. And then for our material 2, which let's go here, material 2, on the group, this one. And there we go. That's how you apply materials to our two different geometries. Now in Houdini, you might apply these to separate geometries not merged together. So you might only have one of these. And there's a couple other places that you might apply materials, but we're not going to get into them now. That's using Solaris and USD. And we're going to stay away from that for a little bit. Here we have the normal and Phong tag. Now by default, it's already being applied. The Phong is already being applied. We can see this is a nice smooth geometry. But let's destroy this geometry a little bit. So I've just converted it to VDB and then back, or volume and back. And then I'm making our normals go super flat. So it looks chunky as all hell. And we can see it kind of looks like it's being carved up. And if we chuck that in our normal node, it's going to try and interpolate our normals correctly. But because this is pretty chaotic, it's not going to do the best job. But the normal node is normally where you get a lot of this stuff. And you can adjust the clasp angle to get more or less smoothing. And then there's another one that is soften normals. And we come in here and that's going to soften our geometry back to something that's a bit neater. And let's do this with a sphere. This is normally where you might see it. So sphere here, it's already kind of got this nice smooth normal applied, but let's mess it up just for the sake of teaching. And then apply a soften normal. And we get our normals softened again. So doing normals in Houdini is just as much as doing a soften normal or a normal node. Or a normal node. That is really difficult to say. Next up is an SDS weight, or subdivision surface weight, which right here we can see we have a subdivision surface and we are smoothing him out because we have a cube with no cuts to him. And then I'm able to create the crease weight by selecting these edges here and then putting a subdivide, and that just automatically does this. But with this attribute create, I had to make sure it was called crease weight. Whatever value I put here, it will subdivide to. So let's go here where we've smoothed it quite a lot. So it's super smooth. And then if we come here and go to 0, this is going to be the same as not having anything. And if we pump this up to 0.5, we can see we start to get that crease back. And the higher values start giving us either no crease or more crease. Can be handy for some different modeling purposes. Now the next one is stop tag. And this is essentially to stop a deformer being applied to all geometry. This is super simple in Houdini. I've got these three guys happening here, and I've got a bend deformer just being animated that we've seen a million times. And in the bend deformer, if I come up to the top, we have group. And now we can delete group, and it will bend everything. But if I come in here and kind of like what we've seen before with our material, we come to select 3D connected geometry. We can select what we want it to be applied to. So if we select this middle pole, only the pole is going to get the bend done to it. Or maybe we want the pole and the bottom. And now they're the only ones that are going to get the bend. Useful in certain situations, but there it is. There's your stop tag. Now for more tags, we've got annotation, which if you just come up to the top, we have these big boxes that I make here. And if I'm not clicking anything and I click it, we get a little box here that we can put nodes in and name it up the top. But we also have this little notes box that we can come in here and write fun stuff. And I spelt that wrong, but that's not important. We can also put in images if we want, like emojis, all these different things can be handy. And that can obviously serve as a to-do list or fun stuff, or like it is up here, being a header for whatever is going on below. And next up is Vertex or color map. This is super simple and something you use a lot in Houdini. And I've got an attribute paint here, and I'm actually painting it different colors. So if I highlight the node and press enter in the viewport, I get a brush. And you can see it's painting it white, but let's paint it, I don't know, this purple color. And that's just only affecting color, which is written here, CD color. So if I reset all changes, come in here and paint, we're going to see this. And you have all different ways of your brush, making it big and painting it however you might want, which can be useful later. And if we come to our geometry spreadsheet here, we can see on our points, we have our colors between 1 and 0 for red, green, and blue. Another version for this is painting a mask, which we have here, which is just kind of like what we just had, but the attribute is called mask that we've named it here. And that's just a float value between 0 and 1, and it doesn't have multiple colors. So it's just going to view up here as red, even though it's literally a black and white mask. And we can do stuff like use that mask to drive a noise, which if I come up here, we can see we have a blend attribute. If I uncheck that, it's going to do it to everything. Blend attribute set to mask because that's what this one was called. And if we come back to our attribute paint, we can literally just paint or remove what we don't want because that is just a black and white mask. You will use a lot of this in Houdini. And to prove that, here are some other ways that we have used these before. So if we've got mask from geometry, I have a sphere and I have a mask, and we can obviously make the radius bigger or smaller. And again, this is just another attribute that's been created, mask, creating an attribute between 0 and 1. And then we're going to apply that to our noise again. Look at that. We can move our sphere, make him bigger, move him around. It's the same idea. Instead of painting, you're using geometry to do it. And Mops fall off that we used a lot before with a little torus here, preview fall off, and then attribute noise. Same idea. We can move this around, do whatever we need, add more. All these things can be done in conjunction with each other, but that is our vertex and color map. Super powerful in Houdini. You'll use this a lot. Now it's time for some selection tags. These are called groups in Houdini, and you'll use these a lot. We've already kind of been alluded to them in a lot of nodes having group up the top, and we actually just selected our own geometry. But you can do that in a previous step by having a group node. So here we have a group node that I've selected, and I've named it tail. And in base group, we've selected all these primitives, because you can select different versions, but this is a primitive one. We've selected the primitives in tail, and then I've used that group name tail to create a material that just makes his tail cyan. We can also apply that to an extrude. So extrude, maybe we want them to be connected, and his tail is, I don't know what this is. It kind of looks like a parachute, but it's being applied to tail. If I remove that group, it does this, or if I select, and if I come in here and, I don't know, select all these, we're going to see, well, it went through, but you can see what's happening. I don't have to have our group be a name, but it can be. And if I come in here, it normally tells us if there is a name. So tail, we can find him. We can do the same with points. So let's go into this group. I've selected some points using a bounding box for this one. So points, it's called head. We have points, and this one's using a bounding box. We can make this bounding box as big as we want. And then I'm just going to apply some noise just to that one little area. And that's, if I come into noise in our group, we have head. We have a different way of doing that as well. We can use by normals and by edges and by random chance. So this one will delete some. And then I've got mountain node. So it's only going to be applied to points with normals that are above this. And if I bring this down, it's going to tighten that clamp. We can go in the opposite direction as well and turn off random chance so it gets them all. There we go. We can also do groups based on edges where I've done some nice loop selections. And we can see they're all here and it's on edges mode. And then I used a peak node to, I don't know, make his tail look like a barb or something. Kind of looks more like a Pokemon now. And that's the idea of selection in Houdini. And you can obviously have all these stacked up. So we can come in here and do points and then do edge selection as well. And they're both called something different. And let me show you where they are. And if we select this here and press I, we're going to see there's an edge group here called group 1 and a point group called top. And let's go back to our peak and let's put these all in line. So we're going to distort all that and then peak just those ones there. So this can be cool for doing many different things, but you can align all these groups and have them in there. And MoGraph Selection works exactly the same way. So let's have a look at that. I have all these guys here using Mops Instancer like we've seen before. And then I've gone and created a group by just selecting a whole heap of points because that's what all these are just packed cubes onto points. And then I'm going to blast them by deleting them. So I'm blasting MoGraph Selection. And there we go. We have deleted all those cubes. Now the same principle applies for copy to points, which is the more generic way in Houdini. So we're doing the same thing with copy to points, this cube to a grid. And then if we come here and make sure this is packed and instanced, because if it's not, I'll show you what happens. But we can create this group here by selecting a whole heap of points. and then blasting them away. Same idea will happen. But if I don't pack an instance, we have access to the actual points of our geometry, and it's going to delete that. So it's not going to look anywhere near as pretty. Delete that. You're actually going to see some geometry cut. So packed an instance will get us out of that trouble. Or better yet, how I'd prefer to do it, and that is to the points before they actually get boxes copied to them. Let's go back to copy to points here, and then let's go create a group onto all these points. You can see this is just a grid, but there's points that I can select at will. And if I blast that, it's going to look a bit ridiculous. It's going to look like it's destroying that geometry. But what's important is all the points are intact for copying our geometry. And this is actually a bit neater and easier to do, and probably the way that I'd recommend doing it. Caching and MoGraph cache. So say you have some complex things going on here, and if I click back to our modifier, we're going to see it's a little slow, and I don't have full control in our viewport. It's not always playing back at real time, and I want to cache it. Caching in Houdini works the same way, whether it's MoGraph or not. And how that is you drop down a cache node, you name it, and then you save to disk. You make sure you select where you want it to go, and we can use some nice tags here to make sure it goes relative to our project file. And then that just will bake out, and we have real-time playback. And that's the same idea if you're doing copy to points. So let's just see, the playback might be a bit slow, especially when I get past cache. And we can then cache out those points. So this time we have this geometry, and then we're just going to cache out that geometry moving around. And then we copy to points after. So that's caching in Houdini, super easy. You're able to select the frame range, save in background, and we have versions, which is awesome. If we go to version 2, there's not going to be anything there because I haven't saved it. So if we make some adjustments and then change it to version 2, we have all those different versions we can come back to. All right, let's have a look at user data / XPresso. We have these two guys here, and I've created some controls which will map to both of these. And this is just changing the resolution of our copy to points or instancing and changing the offset of the size of these cubes. Now what's happening here is in controls, I've come and just created a float slider. So it's coming here. What you can do in Houdini to create user data is this little cog up the top, click him, go edit parameter interface, and it's going to bring up this scary looking thing. But what you can do is over here you have all the things that you can bring in for user data, and here is the user data that you are putting on this node, which is a null in this instance. So let's bring just a float over and let's call it tester. And we can call it tester here, and we can go apply, accept. And when I come in here, we have this. It doesn't do anything, but it's there. And we have access to many different types of data, like color, integers, angles, many different things. There's like ramps and separators and UV, you name it, even file and folders, which is cool. And what I do is if you come in here, you can see this one has like a tealy color to it. That means it's got data. And if you click the name, it will show you what data is controlling that. So this is where the XPresso part comes in. And the cool thing with Houdini is everything can be connected. So let's come in here and go delete channels, which will get rid of everything for us. And now when I come in here, we can see something's happening. And that's because I have it tied to the box as well. But I want to tie it to the points from volume. So let's go into the points from volume. And if I move this, it just gives us more points, more or less points, right? And I want these two to match. So first up you might do is come in here, go point separation. If you go right click and go copy parameter, and then come to your next one and come to your point separation and go paste relative references, it's going to do exactly that. So now already these two are linked, which is awesome. But maybe I want them linked to a null control. So let's come to our null control, copy parameter, come into our points from volume. We can even select both of them if we want and just go paste relative references. And now they're both referencing this null. And proof will be if I come here and we do this, now we're getting the resolution. And then what else I did is get this box, and I am tying the box to our separation minus our offset. And that offset just is going to, if I put it 0, they're going to be exactly the size. And the more I bring this up, the smaller those cubes get. And then I also applied a color node, and I did the same thing here. So let's actually delete that, delete channels. And now those colors are, let's just make them all red. And I want color 1. If I just come here and click color 1, copy parameter, go color 1, paste relative references. And now it's going to be the same as our color here. And maybe we want color 2 to be the same as color 1. I don't know. Maybe I can go copy parameter of color 1, paste that to here, paste relative references. And now it's looking at color 1, and color 1's looking at our null. Might come in handy. You never know. But that's how XPresso and user data can be done in Houdini. It's super powerful because everything can be connected to everything, and everything can be mathed with another thing. So use it where you need to. Which brings me into the final one, and that's Python. And I'm not really going to go into it, just more telling you it exists. There's a few little things. It's like move all points up. And if I click it, we have a grid, and we're going to move them up to whatever I type in here. It's not that exciting, but I'm sure there's more complicated things you can do with Python, but more telling you it exists. Now for everyone's favorite, and we have simulation nodes and hair. Here I just have a cloth that is interacting with a sphere and another sphere that's also interacting with that sphere. Exciting, right? I just want to show that your simulation tags exist in Houdini, and that's probably as obvious as hell because, I mean, that's what Houdini is, and I'm just more showing you that it exists. So we have our vellum here, which works as our cloth. Let's just look at the RBD. We have a sphere that's being transformed up, and then we have another sphere that's just big, and that's getting piped in. If I zoom in here, we have all these little inputs to our RBD bullet solver. Input is the first one. Constraint geometry, which we don't need to think about yet, proxy, and then we have collision geometry. So that just means our sphere here is going to collide with this other sphere. And if we click the RBD solver, we have all our forces and that. Again, this is not a tutorial on simulations in Houdini because that will take a very long time, and there's much smarter people out there that can do that than me. But I'm just showing you that we can have collisions, and then I'm running this simulation, running it all through here, and then that collision is coming into our cloth collision. We have our cloth coming in here, cloth collision. And if we go to our vellum solver, we have our collision. Yay! And for belt, we can come in here and create a group that is going to select one single point. Let's make it a point. Let's make it all these points. And then I'm transforming just that group, pin group, up and down. Cool. And then that's running into our vellum cloth here, which I have our pin points. And let's turn pin points on to pin and have them permanent and have them match animation. And that's going to be effectively our belt. Let's cut the cord on the interaction here. But there's your belt. And also we have hair, which I just have a grid. And I have a sphere affecting our hair. This is riveting, right? I have a bit of a noise applied to our hair, but this is just proof that it exists, and it's just using vellum. And like hair, we also have pyro, which again, Houdini is famous for. But it is there, and that's more what I'm trying to get at here. That's most of the cool tags you're probably familiar with using in Cinema 4D, and where they apply in Houdini.